Let's start with question number 13 on the test review number 2 worksheet. Number 13, is a scale factor of 8 to 5 a reduction or an enlargement? Explain why. Well, 8 to 5 class is just the fraction 8 over 5, and we know that is greater than 1. So for our answer, we're going to say an enlargement oh goodness, sorry about this. Let's try to write where you can read it. This is an enlargement because 8 over 5 is greater than 1. So we know it's an enlargement. Your scale factor is greater than 1, it's going to be an enlargement. Take a look at question number 14. Number 14, is a scale factor of 1 to 6 a reduction or an enlargement? Explain why. Well, 1 to 6 is actually 1/6, and that's less than 1. So this is, I'm going to write the word "and." This is a reduction. Because, when it says explain why, you got to tell me why. Because 1 over 6 is less than 1. Always a reduction when the scale factor is less than 1. Let me fix that. 6. And we'll move on. Number 15. Label the preimage and image, then write the scale factor as a simplified fraction. That means don't change it to a decimal. First diagram, okay, our preimage is always the shape that doesn't have the prime notation on it. That means there's our copy or our image. Remember, scale factor is always image over preimage. Our distance to our image is 2. Our distance to our preimage is 24, and we can reduce that to 1 over 12, and there is our final scale factor as a simplified fraction. Notice that's less than 1. That makes sense because we're going from preimage to image. That's a reduction. Let's take a look at the next one. Our preimage now is the smaller shape because there's no prime. That means this is our image. It's going to be an enlargement, so we better have a number greater than 1. Again, always image over preimage. Our distance from the center of dilation to our image, we don't have a distance. So because we don't have a distance, now we're going to compare corresponding sides. We know this side, and you know what? There's an error on this I see right now. Class, let's fix this. Unless it's already fixed on your worksheet, this 4 should actually be over here. It has to be a corresponding side. Otherwise, we can't find a scale factor. So now we've got on our image, our side length that we know is 26. Let me change that back to green. And the same side, or the corresponding side on our image is, on our preimage is 4. We can reduce that. 26 and 4 are both even. They divide by 2. That is 13 over 2. And there is our simplified fraction for our scale factor. Let's take a look at question number 16. A student wants to find the height of a tree. He places a mirror between himself and the tree and creates the diagram below. Using his sketch, find the height of the tree. Well, let's go ahead and set up our proportionality statement first so we get these set up correctly. I can see that angle D and B are right angles. So those correspond. And then you can see, class, angle C in both of these triangles is the same measure, same degrees. So those are corresponding vertices, and that means E and A must go together. So now I'm going to write my proportionality statement. First I'll write my similarity statement. Triangle, let's start with D, and then we're going to go from the single circle to double circle to no circle. And that's got to be similar by the AA theorem to single circle, that's B, double circle is C, and no circle is A. Now that I have my similarity statement, now I can write my proportionality statement. DC over BC is equal to CE over CA, and that is equal to DE over BA. We know these are our corresponding sides and they must have the same ratio. All right, what sides do we know? We know DC. We know BC, the bottom one right there. We know AB. And the good news is we're looking for DE, which is the height of our palm tree, and that's right there. So we can go ahead and write our proportion. We're going to use DC over BC equals DE over BA. Let's plug in what we know. So we've got DC is 158, BC is 32, DE is our unknown, BA is 67. Oops, I wrote 64. 67. We're going to cross multiply now. So we've got 32x is equal to 158 times 67. 158 times 67. Oops, that didn't work. 158 times 67 is equal to 10,586. And now we're going to divide both sides by 32. Let's divide this by 32. And we've got 330.8 is rounded to one decimal, so approximately 330.8. So our final answer is the height is 330.8, and we're looking at inches here, so inches. Here's our answer. Now technically I should put the word approximately. I'm going to go ahead and do that. Is approximately I'll just put APPROX, approximately. Alright, so that's how we find the height of an object using similar triangles. Number 17, the Empire State Building is 1,454 feet high and 187 feet wide. That is one tall building. If you want to build a scale model that is 1 foot wide, so we're going to make a really small replica, it's only going to be 1 foot wide, how tall would the model be? Well, the first thing I'm going to do is I'm going to label what I know. I know it's going to be 1 foot wide here, and I'm not going to know what the height is. And on our actual Empire State Building, it is 1,454 feet high and 187 feet wide. Now, because all my units of measures are feet, I'm not going to write feet on any of these. I know we're dealing with feet. Okay, now, the way I taught you to do this is set up a table, and let's go ahead and do this. There's lots of ways to do this table. The way I'm going to do it is I'm going to say, okay, on the top, I'm going to say this is my real Empire State Building, and this is my model. I've got a real one and a model one. And then over on the rows, I'm going to put, this is going to be how tall it is, and this is going to be how wide it is. So I just took all the information from my question. I know there's two buildings, a real one and a fake one, and I know two dimensions, height and width, or how tall and how wide. Let's plug in what we know and then what we don't know. Well, the height of the real building is 1,454. The width is 187. The height of the model, I don't know. That's what I want to know. The width of the model is 1. Now watch what I'm going to do here. I'm just going to go ahead and turn this into a proportion. Put an equal sign right here. So I've got 1,454 over 187 equals x over 1. Let's cross multiply. X times 187 is 187x. 1,454 times 1 is 1,454. Divide both sides by 187, and you're going to get approximately 7.8, and that's our unknown height. So my final answer is, we're asking how tall will the model be? My final answer is going to be the model will be, and I can use approximately again, approximately 7.8. Now our unit of measure here is all feet, so 7.8 feet tall. And there's our final answer. All right, let's go to question number 18. I got to go pretty quick here because the video is going to get long otherwise. Let's take a look at question number 18. Dilate the shape on the graph by a scale factor of 1 to 2. Class, 1 to 2 is 1/2. Okay, if the scale factor is 1 to 2, that's a reduction, and that means I'm going to have a smaller triangle than my original. And label the image vertices using prime notation. Our center of dilation is the origin. Let me show you how to do this, an easy way to do this. Well, the way I taught you in the flipbook is to take your existing coordinates and translate them through a translation that's a dilation. That means the x value is going to be 1/2 x, the y value is going to be 1/2 y. So you can go through every one of these coordinates. We can go to z and say z is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So z is at 10, 8, and that's going to end up being 5, 4. Now there's one way to do it. I can plot that point now. 1, 2, 3, 4, 5. 1, 2, 3, 4, and there is my new z prime. There's a faster way to do this, and that is, let's count out our other coordinates. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. Actually, you know what? I'm just going to work this out. Y equals 10, 2. Let's just do it the correct way, and that's going to be 5, 1. And then my w value is 1, 2, 3, 4, 5, 6. 6, 2. We're going to cut those both in half. That's 3, 1. Let's plot those points. Y is going to be right here at 5, 1. And that's y prime. And then w is going to be at 1, 2, 3, 1 right here. W prime. And let's go ahead and connect those together quickly, if I can do it quickly. There's my first line, second line, and third line. So using using transformation notation, we can easily dilate the shape. Let's take a look at the next one. Dilate the shape on the graph by a scale factor of 3 to 1. Well, think about this. 3 to 1, that is an enlargement. So we're going to get a bigger shape. Now I'm going to show you the shortcut method. A little bit faster. We know that our transformation is going to look like this. xy is going to become 3x, 3y. Watch what I'm going to do. 1, 2, 3, 1. S is at 3, 1. So I'm going to triple that. 3 times 3 is 9. 1 times 3 is 3. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Now most of this math I'm showing you can actually be done in your head. But if you're having difficulty with that, then just work the problem out longhand. Same thing I'm doing here. S is at 3, 1. That's going to become 9, 3. Now here's what I can do that will make my work a little bit faster. If I know my scale factor is 3, then I know from S to W the length's going to triple. So S to W is 2. That means my distance to W now will be 2 times 3 is 6. 1, 2, 3, 4, 5, 6. Here's my shortcut. So that's now W prime. And now let's go to T. The distance from W to T was 1. We got to triple that. Now it's got to be 3. 1, 2, 3. And there is my T prime. So there it gives you a little bit faster way. Once you find one of the points, you can actually use the original triangle and just scale it by whatever your scale factor is. Let's go ahead and connect those up now. So now I've got S to W, T to S, and W to T. On this question class, the number one mistake students make is they forget that you're being asked to use prime notation. Don't forget to label your letters. All right, we are almost done. Let's get down to number 20. Using transformations, prove the two shapes on the grid are similar. I have already written down the transformations to save some writing time. When I look at this pre-image, I can tell that I'm going to have to reflect it up on or above the x-axis. And when you reflect, don't forget to count how far away you are. 1, 2, 3, 4. 1, 2, 3, 4. Now you can see, let's go ahead and connect our points. There is my reflection on the x-axis, which I wrote down below already for you. And that is triangle 1. And then we have a translation over to triangle number 2. We're going to move over 1, 2, 3, 4 to the right, and we're not moving up and down at all. So all we're doing is adding 4 to the x value and leaving the y value alone. There's our first transformation. I hope you're practicing these. Here's the next one. This one's a little bit more difficult. It has a rotation, and with a rotation, I like to work out my points. So I can see that to get from pre-image to image, I'm going to have to rotate this. And it looks like I'm going to rotate it this direction, which is clockwise. 90 degrees. If you look at my hints up on the top, you see a rotation of 90 degrees clockwise. XY becomes y negative x. So XY becomes y negative x. Let's plug in what we know. I'm going to go ahead and take this point first. Negative 1, 2, 1, 2, 3. So I've got negative 2, 3. And that's going to become the x value. Sorry, the y value moves to the front. That's now 3. The x value moves to the back of our coordinate, and the sign flips. So our new coordinate there is going to be 1, 2, 3, 1, 2. There's our first point. I'll do these in different colors. Okay, next one. My next point I'm going to do is this bottom one. 1, 2, 3, 4, 5, negative 5, 1. The y value is going to now move to the front, so that means this 1 is going to move to the front. The x value moves to the back, and the sign flips. So now our point is at 1, 1, 2, 3, 4, 5. Now don't guess which way the triangle is. Do the third point so you don't make a mistake. The next point is 1, 2, 3, 4, 5, 1, 2, 3. So it's at negative 5, 3. Remember, our y value moves to the front, our x value moves to the back and flips sign. So we've got 1, 2, 3, 1, 2, 3, 5. Here is our last point, and now that works out good. Looks like we've got a rotation that got us in the proper orientation. Quickly draw that. There is my location 1, and I wrote down the rotation transformation for you. And now we've got translation. We're going to do 1, 2, 3, 4 to the right, and 1, 2, 3, 4, 5, 6 down, and there's my translation. All right, that's the end of this video.